So hello everyone, in this video we will be solving another LeetCode problem, and the problem name is delete nodes from linked list present in an array. So let us read the problem statement first. So you are given an array of integers nums and the head of the linked list, and you need to return the head of the modified linked list after removing all the nodes from the linked list that have the value that exists in nums. So what the question is saying that you are given a linked list and you are given an integer array nums. So you need to remove all those values that are present in nums from this linked list and return the new head of the linked list. So this is the problem statement. It is pretty much simple. So the question is around the linked list, so we can obviously think that everything we will be playing with the help of pointers, because whenever there is a linked list question we think in terms of pointers only. So in this question also we will be solving this entire question with the help of pointers. So the problem statement is pretty much simple. So you just need to remove the nodes from the linked list that are present in this array nums. So how will we solve this question? So let us take this example and try to see how we can solve this question. So let us see this example. So this is the example that I have drawn here. So the nums here was, I think, yes, 1, and the linked list is here only. So this is the initial head of the linked list, and what we need to do, we need to remove the nodes that have the value 1 from this linked list. So how we can do that? So first of all, we need to find the new head of the linked list. Now why new head? Because it can happen that the head which is currently pointing to the node, it is itself the value which we need to remove. So first of all, find the node that is not present in the nums array, because from here only we'll be starting the iteration, because that particular node will be the new head that we will be returning. So first of all, remove all the nodes from the beginning that are already present in the array nums to get the new head of the linked list. So what we can do, this is the current head, right? So we can initialize the pointer cur here, and we'll be iterating until the value of the current node is present in this nums array. So instead of array nums, what we can do, we can initialize a set which will be containing all the values of the nums. So in this case there is only one value, which is the value 1. So we'll be storing one value in this set. Now we'll be iterating to the entire linked list until and unless we get a node which is not present in this set to break from the loop to get the new head of the linked list. So here we are currently at this initial original head of the linked list. So we will check if this value is present in this set or not. If it is present, we will move on to the next node. So yes, 1 is present in this set, so we will move our current pointer to here. So this is our current right now. We will again check if this node value is present in the set. So node value is 2. So 2 is not present in this set. So we can say that obviously this will be the new head of our linked list. So we can say that okay, this is the new head. Now for now we will break the loop here, because this was just to get the new head of the linked list that we will be returning in the end. So we can say that okay, this is the new head of our linked list. Now let me redraw this with the new head, and then we will again start iterating through the linked list to get the final linked list after removing all the nodes which have the value 1. So let me redraw this linked list again for better understanding. So I have drawn the linked list again for better understanding of this problem. So we will continue our iteration from current only. Now we have already removed all the nodes to get a new head from the beginning. So we will now continue our iteration to remove the other nodes from our linked list which are remaining to iterate. So we are currently at this position. So we will check current's next value. Why we are doing so, you will automatically understand when I will dry run through this example. So current's next value is this 1. Now we will check whether this 1 is present in a set or not. So yes, 1 is present in a set. That means we need to remove this 1 value. Now can we say that, like, by not technically removing this 1, we can just remove the link between these two nodes and point it to this 2, then we can say that yes, we have eventually removed this one node from our linked list. So that's why we are just checking current's next value, not the current's value, so that it is easier for us to play with the pointers and its next value. and to change the link between the nodes. So we are not eventually like deleting this node, but we are breaking the link between these two nodes such that this node will be now pointing to this node's next value. So eventually we have broken the link between them, so this node will never come into existence again. So yeah, what we are doing, if we find, like, let me just erase this part. If we find that current's next value is present in our set, that means that next value is to be removed. So how will we remove that? We will change this pointer. Now what is this pointer? This pointer is nothing but current's next. So this current's next pointer will be changed to current's next. What is current's next? Current's next is this, and its next is this too. So we will point it to current's next. So this pointer will be broken from here and this will be pointing to here. So eventually we have deleted this node successfully. Now our current will remain here only, because we don't know, like this node could also be 1 again, we don't know. So we can't just move the pointer also ahead, current equal to current next. No, our pointer will remain here only. So again we will check whether current's next value is present in this set or not. What is current's next value? Current's next value is 2. So no, 2 is not present in our set. So yes, now we can say that now we can move a pointer ahead because this node value is not present in our set. So we will eventually move our current to here. So now our current is pointing to here. Now again we will check whether current's next value is present in the set. Yes, current's next value is present in the set. So simply change the link between those two nodes. So we will change the link of current's next to current's next. Current's next is this and its next is this. So current's next will be this. So yes, again we will check. We will not move the current now. We will move current only when we are sure that current's next value is not present in the set. Again we will check whether current's next value is present in the set or not. Current's next value is 2. 2 is not present in the set. Now we can say okay, move it to the current's next. So now current will be pointing to here. And since there is no next value, this is end of the linked list, we can return the new head of the linked list. Now how will our linked list would look like? Let me just show it to you again. So yeah, our new head is pointing to this 2. This is our new head. Then 2 is pointing to 2. Then 2 is pointing to 2. So there are nodes in between, but what will happen that these are in no way connected to the original linked list. They are just pointing to the nodes of linked list, so they are of no use. And since this node will not be counted because we will be returning our linked list starting from new head, so there is no importance of these nodes. So eventually we have removed this node from the linked list. So let me just show you or walk you through the code, which is exactly similar to how I just explained the entire solution. So let us see the code now. So initially we'll be like using the unordered set because we don't like need to maintain the order. So that's why we are not using ordered set. We are just using unordered set just to check whether the nums value is present like in the set or not. So eventually first we'll be inserting all the nums value inside the set. Now first we'll be finding the new head of the linked list. So this is for the new head of the linked list. So we'll moving a current pointer until we are finding that okay, this particular current's value is present in the set. So if current's value is present in the set, just move the pointer ahead. Else if you find any node that is not present in this set, that means from here we need to start our new head. So in the example 2 was the new node or the new head. So we have started or we have pointed the new head to 2. So this is where this is what the condition was. So if you find any value that is not present in the set, that means it is the new head. So break the loop and mark that like current node as the new head. Now continue your iteration to delete the remaining nodes from the linked list. Now until you reach the end of the linked list, just do the following operation. So you will check whether current's next value is present in the set or not. If it is present, you will change the link between those two pointers. And what will be, how will be changing that? We will be changing like current's next equal to current's next as we have seen in the drawing explanation. Otherwise, If that value is not present in the set, that means we need to include it in our final linked list. We will just move our current to current's next pointer, and in the end we'll be returning the new head of the linked list. So this was about the solution of this problem. So I hope you understand this solution. Thank you.